What you see behind me is a 2001 Audi TT, and in this series, we're gonna see, is it a good idea or a bad idea to buy someone's unfinished project? I have a feeling is not gonna go very well. 3 years ago, they took the engine apart to do some modifications and never finished putting it back together. Legend has it that he took the engine apart, had the block 0.5 millimeter overboard, and when he was putting it back together, broke a piston ring, and then the project sat. When I went to pick the car up, it was on jack stands and parts were everywhere. All in all, I'm in it for $1,300, including the car and all the stuff that we're gonna check out today. I have tubs and tubs of parts. I don't even know what we got. I do know though, that when I went to pick the car up, everything was everywhere. So what we did was we just basically put everything in the back of the TT that would fit. So what we're gonna be doing is we're gonna first go through everything that I have for the car, see what we're missing, see what we need, and hopefully get the car put back together. And big thanks to Advance Auto for partnering with us on this video. Even though the previous owner said we have everything to put the car back together, I guarantee you we most certainly don't. So my question is, how many parts store runs is it gonna take to get this thing finished? I haven't dug through any of this stuff, so these piston rings and these IE forged rods, and I think these are Wiseco forged pistons. I bet if we would have ran these pistons in the Jetta, we wouldn't have blown it up with nitrous. What's cool is, this is a 1.8 turbo, so very similar to the 1.8 turbos that were in the Passat and the Jetta and the GTI. This guy bought a ton of performance upgrades from CTS, and then unfortunately the car just sat. So we got an upgraded turbo. We got some good parts. We've got some new springs in this guy. Also, what's fun, some of this stuff might not even go to the TT. I'm pretty sure this is for like a V6 Passat. What is good though is he did buy a bunch of new stuff, and a lot of this stuff is in like super good condition, like these dust shields. I just foresee like getting it mostly together and then sadness because we're missing parts, and then getting it together and then sadness. Here's the stock piston. You can see it's kind of scraunchy looking, just for comparison's sake. This is 0.5 millimeter bigger than this one. He said he got new rings when he broke that first one, so maybe we'll make some trophies out of these pistons. I didn't like sort through and really dive into what we did and didn't have, but one thing I don't remember ever seeing is a clutch. And a lot of stuff like timing chain, we'll end up replacing. I got this car for 1,300 bucks. Those pistons and rods are basically $1,000, just that. So it was one of those like no-brainer kind of things. It's like you can't pass up deals like this. They don't come about all the time. So when they do, I feel like you have to capitalize on it. And you know, it's cool. Hopefully it'll be a cool little like put together project. And then we'll sell the car and move on. My big concern is like bolts and hardware. I mean, we could be missing stuff. We could have more stuff. There's some nice piping in here though. These are all exhaust manifold studs. Probably an oil feed and return line. Oof, man, that's some nice piping though. Now I also have cylinder head over here, and I got the block down here. The crankshaft is in the block with the car sitting for 3 years, and like, it was just chilling on the engine stand. We're gonna send it to the machine shop and have it checked. I have learned in my career, don't trust other people's workmanship. So we're gonna live by that rule. The head looks good. He said he didn't have anything done to it. Oh, you know what? Maybe this chain looks new. The gasket looks older. Maybe he did do something with this. Ugh. 5 valves per cylinder, friends. 3 intake, 2 exhaust. Oh, there's some crustiness in there. Yeah, we're definitely gonna send the head to the machine shop. They'll also clean it, which will help me feel better going back together with it. It broke the shelf the first time I put it on here, so. Turns out you're not supposed to put transmissions and engine blocks on these shelfy guys. So it did go to the machine shop. It is 0.5 millimeter bored over, allegedly. Oh, Lord. I want to make sure we don't have any like severe marring. I mean, the whole thing looks pretty good, but I definitely think we need to send this. And I think that's probably going to end up costing me new bolts, but I think that's going to be well worth it. For our final tub that we have, this looks like it's mostly gaskets and a flange. Nice. Magnetic drain plug, timing belt, SERP belt. What? We got a freshy oil pump. Look at that. He said he was trying to build this car for 400 something wheel horsepower. If I remember right, there was nothing wrong with this car. He just wanted more power. And you can't really blame the guy for that. Let's go back to the trunk and get all of what I think is like all stock stuff out of the back. As you can see, there's a lot back here. A lot of coolant piping, that's what this is. A lot of this stuff is gonna be, to quote my good friend Paul, guess and check. For some of this stuff like this, we'll probably end up doing the metal upgrades to the Y-pipes. Now this is the lower trim version of the TT, the 180 horsepower. There was also a 225 horsepower, unfortunately, which is not this one. This is all secondary air stuff. This car might end up being off-road use only, so maybe we'll delete it. So far I know we don't have a clutch. I also haven't seen an ECM. On a must replace parts list, this crank position sensor will probably get replaced. Here's our OE timing belt. We have our oil filter housing. I didn't see an upgrade for this, so we may reuse that. Another engine mount. We'll probably be replacing those. This is kind of fun, really. Some rando bracket. If you've ever wanted to see the world's stupidest convoluted PCV system, welcome to a 1.8 turbo Volkswagen. Yeah, we're not putting any of this nasty junk back on. Got a dipstick and a broken funnel. Those came standard on 1.8 turbos. Stock exhaust manifold. I haven't seen the stock turbo. A lot of rando piping. This is gonna be a fun puzzle, but I can already tell you, we're 100% missing stuff. We're gonna get to a point where we're going back together. Oh, there's the stock turbo. And we're gonna find we're missing more than we thought we were. Here's the factory turbo. Look at how little this is compared to the other one. She's so little. This is the stock intercooler, and we're gonna be dropping this because we have that giant front mount. So this is a side mount intercooler, but I'm now starting to get nervous about the ECM. Here's the combi valve. Here's our intake, but we have a starter and an alternator with a bad one-way clutch. We also have our old scraunchy headlights, but he bought new ones. They're also very dirty. Yeah, that's a street shield. I actually don't feel terrible. We know we don't have a clutch. Almost guaranteed we're gonna be missing hardware. We need to send the block and the head to the machine shop to have them checked. I didn't see rod bearings. Then I guess we wait till that stuff comes back. So I figured we probably should get this car up in the air and just see if there's any like super major catastrophic issues. And I really don't see any right now, thankfully. I'm looking at this exhaust and feeling like we're almost surely gonna really need to put an exhaust on this car. This is a 180 horsepower, not the 225. I think the 225 had a different exhaust, but you can see it's like crushed in over here, similar to the R32. In fact, minus being a 1.8 instead of a 3.2, this car is almost exactly the same as an R32. I mean, you can see the pinch welds are a little sad, which is kind of standard operating procedure. I feel like this is probably not a factory axle, because generally they don't rust that way. I guess we'll worry about that when we need to worry about it. In preparation to send our cylinder head to the machine shop, we need to do a handful of things. First, I'm going to take off all the cam caps and the camshafts. This will give me the opportunity to inspect all of that for any damage from maybe oil starvation or wear on the bearings. I'm also going to remove the timing chain tensioner and inspect that, and I'll pull out all of the lifters. This is pretty much a mandatory step for sending a cylinder head to the machine shop. The reason I'm going to send this to the machine shop is so that they can, one, clean it, and two, do a leak test to see if we have any worn valve seals or valve guides. I'll likely have them replace the valve seals and guides anyway, and who knows, maybe I'll have them throw in some upgraded valves while they're in there. Similar to how we stripped down the cylinder head, I'm going to do the same thing for the block and send it over to the machine shop. Because the block was already machined, I'm only sending it over to just triple check and make sure it's right. This might be a little bit of overkill by having this rechecked, but I would hate to get it all back together and have a real problem with the machine work. But thankfully, the bearings look good and the crankshaft looks good, so hopefully I'm just paying for a bit of peace of mind. So after what seems like forever, we finally have our engine back from the machine shop. What initially was supposed to be installing some new valves and springs kind of turned into a disaster. When I sent everything over to the machine shop, the cylinder head portion was super easy. New valves, new guides, new seals, valves, and valve springs. Valves and valve springs are a pretty common upgrade for the 1.8 turbo heads. This also gave us the opportunity to order a handful of those parts that we knew that we were missing and expecting that we would probably have more that we ended up needing. Now, the bottom end had already had machine work done, so really all I wanted was just a quick check over to make sure everything was good. And this is where we ran into a problem. The block was bored over 0.5 millimeter to support the upgraded forged pistons. Well, unfortunately, the piston to wall clearance on 2 of the cylinders was not done correctly, so the holes were actually bigger than they should have been. This left us with 2 options. 1, get another block and have it rebored properly to achieve the proper piston to wall clearance for the pistons that we have. The other option is to get new pistons and rebore the block that we initially sent over. Since new pistons are 1, not super readily available, and 2, real expensive, we decided to go the route of getting a different block and just having it remachined. We were on the hook for getting the block bored anyway, so I figured we'll take the more affordable route. Now, thankfully, 1.8 turbo blocks are readily available. I bought one for 50 bucks and I found the main cap was destroyed. Now, even though that issue is repairable, like I said, the blocks are really cheap and pretty easy to find. So thankfully I got my 50 bucks back. I was able to find another block from Everything Euro while we were getting the Mark 8 dynoed. So we grabbed that, brought it, stripped it down, and sent that to the machine shop to be rebored. Now it's time to wrap up the cleaning and get this engine together. Now, since everything's been measured, these caps are actually torqued down. So we're gonna remove the caps, we're gonna remove the bearings, and then do a little bit better cleaning on the block. We would have to take these caps off anyway to put the crankshaft in, so we're really not doing any extra work. And we're gonna keep these all lined up in order since we've already made our measurements. Now for the third one, we also need our thrust washer to be installed. We'll make sure we get that set up too. Now overall, our block is in pretty good shape, but like all this old sealant and where the water pump goes and where the thermostat goes, we want to get all that as cleaned out as we can now. If we do it now, we just take some compressed air and blow all this yuck out, not have to worry about getting yuck in a place where we don't want any yuck. Our first order of business is going to be getting our piston squirters in. Now I actually have 2 sets here because, well, that's how many we have. And what these do is these mount in the block and they actually squirt oil up underneath the piston. Now you'll notice there's holes all around here, and then in the bottom of where the thing is threaded, there's this little silver piece. This is actually a ball, and there's a spring inside the body here. Now I have one that's bad, that ball just moving around in there when I poke it with a toothpick. This is bad. We don't want to put this one in. We do want to put these in. And then the way you can clean these is just spray some brake cleaner in these holes, and then just give that ball a push, make sure there's no yuck stuck in it or that it's clogged or like carboned up. It does need to move a little bit. Take this little guy, be careful, and just flush it out. That was more than I expected. We'll go ahead and get the rest of our jets installed. These are basically just for piston cooling. You do want to make sure that it's seated all the way and doesn't get all spun sideways on you. Now, because we had one that was bad, I got to use one bolt that's different. So we'll go ahead and torque these again, 27 Newton meters. And just to satisfy my OCD, we're gonna mark these so we know that they're torqued. It is time to clean our main journals. Even though this thing has been to the machine shop and all that, look at how much dirt gets left behind. So it's a good idea, always, always, always to get these nice and clean. Not only the bearing surface, but where the cap goes to is a good idea to wipe down. And if you hadn't already done, clean and blow out these holes for our main bolts. On most Volkswagen Audi engines are one-time use, unless you're going like ARP or something like that, then you don't have to get new ones, you can reuse those. Go ahead and drop our bearings back in next. Now, because I've turned the block around, let's go ahead and turn the engine back around the other way so that we don't end up screwing it up. Now that we're back in action here with our goodies facing the proper direction as we took it off, we can go ahead and keep on keeping on with our bearing installation. I'm also cleaning these as we go, mostly the backside of them where they go into the block. These babies being clean and dry is important. If you've ever heard someone say, I spun a bearing, what happens is either this bearing or a rod bearing will come unseated and it'll rotate independent from the crankshaft, cause a big old mess. Now this is the crankshaft out of the block that came with the car. The reason we used this one was the second block we used, the bearing surface was destroyed, so the crank was basically junk. All the measurements and everything were taken off the crankshaft that we got with the car, the original crankshaft from the engine, and all the machine shop did was polish the journals and make sure everything was good. So really, the only thing we need to do is just get this cleaned up, clean our bearing surfaces, and then put it in. It may seem like I'm overkill on cleaning stuff. We're not making microchips, as I often like to say, but if we have the opportunity to clean something now, it's gonna be easier to clean it now than it'll ever be again. Take the extra 5 minutes now and get it done. We'll go ahead and wipe our bearings down. These should be fine. Next up, we'll get our installation paste. Pre-lube these guys. This will help on initial startup. Make sure these are nice and coated. We can go ahead and set our crankshaft in. Awkwardly balance this here. There we go. The engine stand kind of gets in the way back here, but that's okay. We are in business. Now, we can go ahead and put our mains on. I not only cleaned where the bearing meets the cap, but also right here where the cap is gonna meet the block. Then put a little looby lube on there. Main number 3 is the one that has the thrust washers in it that control how much movement back and forth the crankshaft has. This is a place where really, if the crankshaft's not damaged in any way, usually these are just fine on this particular engine, but this is one of those things that it's not gonna be easy to reinstall after the engine's all together, so I'm gonna go ahead and put new ones in rather than reusing the old ones. You know you'll have the correct main cap with the thrust bearing because it actually has a cutout specifically for it, and the bearing sits in the channel like that and pokes down through to the lower cap. Not only am I gonna put some engine lubrication and installation paste here, I'm gonna put a little bit right here. All that's really gonna do for me is hold the thrust washer in place while we get it installed. Usually I like to do this one either first or first and second so that you have a little bit of crankshaft movement just in case you need it. I'll just go ahead and do the rest of them exactly the same. I usually start the bolts by hand. Then what I'll do is I'll take a rubber mallet and just give them a tap, tighten our main cap bolts down. The torque spec for these is 65 Newton meters plus an additional 90 degrees. I usually like to spin the crankshaft and make sure it actually spins. Oh yeah, ooh, that's real nice. Now for the plus 90, you can do your angle wrench if you prefer to do it that way. I like to just put a mark, usually around 12 o'clock of the bolt, whichever way you want. Going back and double checking torque is easy. If it's 65 Newton meters, you just go back and put the torque wrench on it. And then what I'll do is I'll go ahead and do our 90. Then at a quick glance, we can go, okay, not only do we tighten them, right, they're torqued, they're also all lined up. So if you missed one, it clearly stands out. Also, after you do your quarter turn, go ahead and give your crankshaft a little twisty. There's probably a little bit more resistance than with it not fully torqued, but as you can see, I'm just rolling this around by hand. Well, now it is time to do, as y'all know, something that is my favorite thing, and that's deal with our pistons. One of the main reasons we got this is when dude was putting it together, he actually broke a piston ring. So here's the stock piston. Here's the modified one. Oh man, it's not even close. Also, how about these old school IE piston rods, huh? So this is what came out of, this might actually be one that did come out of the engine proper, and then this is what we're putting into it. Quite a bit of a beefy boy over this thing. We're gonna have to make sure we do a couple of things. One, we need to check and set our ring end gap. So I built this little contraption here. We have our oil control ring that goes at the bottom. The other two rings, two compression rings, are not labeled. So what I did was I just set the piston out. I laid each ring in the piston. And there is one that fits real nice in the top groove, and the other one is too big. So we know that the darker ring, the one here, goes in the middle, and this one goes in the top. So I like to put them that way. We're gonna do that for all three of them. We don't want to have too high of cylinder pressure, meaning our gap is too small. We also don't want too big of a ring end gap. Then we're gonna get too much blow by and the car will burn oil. So really we need to find the balance of the two. We have our piston. We have our two rings that we need to measure our piston ring end gap on. This is the ring that goes lower in the cylinder, so we can start with that. First thing I usually do though is I just make sure there's no like hard burrs or anything on it, so that when we slide that ring down, it doesn't score up or scratch up our cylinder wall. So we'll take our piston ring, squeeze it together a little, flip it down like that. Now, unlike on most of the rest of these we've done, like the VR6s, we can take the piston, we can set it down, and that'll sort of flatten out the piston ring. Now we know it's even. Now we will take our feeler gauge set, and we are looking for 0.406. So I don't actually think we're gonna need to file that one at all. We'll do our top ring. Now I'm not gonna push the top ring quite as far down in the cylinder as I did the middle compression ring. You can see how it's not lined up right here. To line it up easy, we just take our piston. That'll pretty much guarantee you have it flat. Okay, so yeah, I can't even get that one in. So we're gonna have to file a pretty good amount out of this top ring, which is not a big deal because we have left over from the blowed up Jetta project a piston ring filer. The key to this though is one, you don't want to take too much out because you can't put it back. The other thing is you want to make sure that the ring end gaps are square. If instead of being straight, it kind of favored going back to the back, that would be a bad thing. So we want to make sure we're filing it nice and straight. As long as you kind of hold it up against these two pins here, it's usually pretty okay. I like to take it evenly off of both sides. I don't know if that really matters or if that's just a habit that I have. Before I'm back with the ring, what I like to do is take a file and just kind of deburr the edges. You just want to make sure there's nothing super jagged. We will wipe our piston ring off to make sure there's no yuckity on there. Then we take it, we put it back in the bore, and we take our measurement again. Slide it into place, take our piston. So you can see our gap there, quite a bit bigger than it was before. Let's test it. We're kind of chasing that 0.4 millimeters. We're pretty much right there. Let's always test the next one up too. If the feeler gauge you use fits, go up one, see what happens. I'm just gonna take a look at my piston. Because these kind of came to us pre-assembled, make sure I don't have any sharp edges on it. Everything looks good. There is one of these rods that had a spot that was kind of boogered up. What I'll do once I have the bearing out is I'll just take this same little file stone and I'll just file it down. It's fine, that's not gonna impact anything. I just don't really like those jagged edges. Next, we are going to pour some hot water so that we can clean our piston rings. Learned this trick from a hot rod engine builder. You wanna make sure that you're doing this kind of quick, because if you leave these piston rings wet, they'll actually rust. Then we'll go ahead and rinse them and then use some compressed air to make sure that they're completely dry. Once our piston rings are clean, it's time to get our piston dialed in for installation. Give these a little taparooski. Now we can take our cap off. So these are new bearings that we got. I went ahead and got some performance bearings because this is generally a weak spot on 4 cylinders. So we'll take our bearing out. We gotta clean that mating surface. Now, I actually don't think I've shown this before. Little trick you can use is a coffee filter, lint-free. They're super cheap and they work really, really well. Look at how much dirt was left behind. This is why it's important to clean stuff. Got some acetone here. We're gonna clean it with this now. Because these have sat out for a while, I'm gonna just give them a quick wipe down. Just wipe the back of our bearing quick. We'll go ahead and get our bearing installed. We'll clean our cap, install our bearing properly. And then these rods are numbered. You see the number right there. When you install them, you gotta make sure your numbers line up. We're not gonna put that on just yet though. Next up, we gotta get our piston rings on. Now this is an area where I have myself made mistakes, broke piston rings. I've also seen other people do it too. In fact, that's kind of how we got here. We also wanna make sure on our bottom ring, which is our oil control ring, that we don't put any of the gaps over any of the oil holes. It's probably not really a problem since we have 3 gaps on that one ring. We also wanna make sure we offset the opening of our other 2 pieces of our oil control ring. So that accordion looking one goes first. Then we are going to put our second compression ring on. Sometimes these are labeled and it'll say top on the piece that faces up or on the top ring. This one doesn't, but it does say N50. So we're gonna put that facing up. Get our pliers. Carefully spread those open and put that ring in. And we'll do the same thing for our top guy. So we want these all about 120 degrees off. Now, as you can see, this piston has a little recess in it for our intake valve. I usually try and not put the ring gaps there. Once we have our piston ready to go and we make sure our ring end gaps are appropriately clocked, we gotta get our tool on. I'll take one of these coffee filters, I'll wipe it out. There's just mostly oil in it, not a big deal, but I will then oil it pretty much. Anything we can do to make this piston slide down in this cylinder easier, usually worth doing. I do like to also make sure that there's no weird gaps. We'll probably have to crunch this down a little bit more, but you also don't need to go to town on it. Then it makes a pain in the butt to drive the piston. So this is what we have. This is what it's gonna look like before it goes in the cylinder. This is pretty much the last time you're ever gonna see this beautiful connecting rod unless it decides to yeet itself out of the block, then we'll see it again soon. Now, we did that basic cleaning of our cylinder bore when we took our piston ring measurements. I also went ahead and put 2, 3, and 4 pistons in because it was late at night, and sometimes I like to do these kind of things just for the pure enjoyment of doing them. Squirt some oil in, just lube that cylinder up. Then what I usually do is I'll grab the filter again, just make sure we're clean. We'll grab our piston. Now, remember we got that little notchy guy that has to face the intake side, which is this way, and make sure that is lined up. We'll just take the butt side, I guess probably more accurately the handle side of this hammer, and just give this piston a tap down until it settles into place. Now, if you're tapping it down and you start to hear a difference in tone of where you're tapping, you might want to stop. What can happen is the piston ring can actually get out from where the compressor is. So this piston ring was actually hitting the block surface. So we need to reset and do it again. Once you have that piston somewhat down in the bore, we need to flip this baby over, and out of paranoia, I usually keep my hand over the piston, but honestly, the odds of it actually just coming out pretty low, so you probably don't need to do that. Now with our rod journal all the way up this way, but basically at the bottom of its travel, a little bit more room to mess around with our connecting rod here. I'm gonna get this pretty close up, get a little bit of our engine lube. I'll just usually hold the connecting rod, tap it up. Now you can see our rod is up at the top. Here is our bearing cap. We'll have to come back and torque everybody. You can run them in by hand. You just don't really want to use the bolt to pull the rod cap together. Take that same old hammer handle I've been using. Give your engine a twist and make sure that you don't really feel any resistance. If it doesn't turn pretty easily with just a basic size ratchet, then you really need to go back and double check and make sure maybe you put a cap on upside down or something else is not happy. Next up, we got to deal with our connecting rod bolts, and there's two main ways that people will properly torque these connecting rod bolts. One is going to be just hit a strike torque value. In this case, IE, who put the kit together for the rods and the caps and the bolts, says 50 pound-feet of torque. The other way is to use something called the stretch gauge. With these ARP bolts, you don't need to replace them when they stretch. They're meant to be reused multiple times. That's one of the advantages, right? What we do is with it in the engine, right? We take our gauge and we put the bolt in between these 2 points. We would tighten this bolt until our bolt was a bit longer. So in this case, they're looking for 6 thousandths, which in my experience, it comes real close to what the recommended torque value is. Couple of things before we get started. One, we need to get some of that sweet, sweet lube on our threads and the heads of the bolts. IE has some really good instructions on torquing these and installing these. You want to make sure you use a good torque wrench and it hasn't been dropped and all that stuff. They say 50 pound-feet is what you would torque it to. That's about 5, so I think we're going to be good there. I think torquing these to 50, no problem at all. I'm going to rotate the engine around just to make sure we didn't do something wild and now have something hung up. Moving right along, it's time to keep going on the bottom end. We need to get our oil pump put on next. Put a little of our engine assembly paste on it. Then I'm just gonna rotate that around, try and get everybody nice and coated. That way we at least have some lubrication on that first startup. We'll get our new oil pump chain. Remember, this is a part that we didn't actually have, and we're just gonna hook it on the crankshaft. Then we'll take our oil return and windage tray, set that, and go ahead and put our bolts in, zip these down. Then these babies get torqued to 15 Newton meters, which is not very tight. We should probably go ahead and put our oil pump chain tensioner on here as well. I'm not gonna put the oil pan on next. I'm gonna leave that for like way down the road. The main reason is I wanna get the front crank seal and the rear main seal installed first. If you do it this way, you can just plop those covers right on and it's no big deal. So this tensioner is just a little spring tensioner. This pin right here has to go up against the block, and that like loads the spring tension, and I just hold the spring, and then that's really all the tension that the oil pump chain needs. That bolt is also 15 Newton meters. Now, before we get too carried away with our camshafts, we need to get our front crank seal on, because this is what's going to end up helping us get our crankshaft time so we can get our camshafts time. This sits on just like that. I like to put the seal in the cover first and then install the cover. You can do these by hand, or you can take a little seal installer and tap them in, or even a hammer. Next up, we got to put a bead of silicone around the backside. Don't worry about the bottom right now. We'll do that when we do the oil pan. You can see where our cover was, the difference in texture between here and here. So that's kind of what we need to keep in mind. Carefully Zoom it right on like that. Then we can just go ahead and get them started. And our torque spec for these babies, 15 Newton meters. Next up, we have to put our timing gear on. Now, this is actually another spot where it's probably not a bad idea to upgrade from this cast gear to a billet gear. But I think for our application, this is going to be just fine. Now, this is also the last time, hopefully anyway, we're gonna see our open cylinders, so make sure there's no dirt or anything in them. And if they're looking dry, go ahead and give them a wipe out. Then we'll go ahead and clean our gasket surface. This is how the head gasket fits on there. You need to make sure that you have not only your head bolts lined up, but all the passages and galleys lined up as well. Since we overbored our cylinders, we need to pay attention to the bore of the head gasket. We only did 0.5 millimeter, so this won't be an issue for us. It's barely opened up bigger than it was from the factory with just 0.5 millimeter overbore. For our cylinder head, use that same cleaning method that we did for the block. Also, I have the cams out still. That's gonna make it a little easier to put this together. All right, like many VW Audi engines, the head bolts are one-time use, and these are kind of unique. Notice that it's threaded down here at the bottom, but it's also threaded with a little bit bigger thread up here at the top. So this threads into the cylinder head, and then this part here threads into the block. Now we can go ahead and get the rest of these guys in here. These are that poly drive that so many VW Audi head bolts are. I'm only snugging these down the equivalent of roughly hand tight. Let's go ahead and get this thing torqued down. We are going to start at 40 Newton meters. Then we're gonna do a quarter turn and then another quarter turn to equal a half a turn. Next up, we gotta load up all of our lifters into our cylinder head, which are these guys here. Then take some of our assembly grease, little boop on the bottom, little boop on the top. I like to always put these back where they came from if I'm not replacing them. You'll at least have the same kind of thing in the same cylinder. You won't cause more damage. And our last intake one, yay. And pretty much same thing for the exhaust. Now the way these work, look, if you look, you can see there's a tiny little hole right there. Oil comes in, this hole right here corresponds with that hole right there in the head. You can see there's like a channel right through here. And that's what supplies oil to these guys. Final one, and then we'll just dab a little dab. This is going to lubricate the camshaft mostly on that first startup before we get all the oil up to the top end. Before we get too carried away with our timing, we gotta get our water pump on because our water pump on this engine is driven by our timing belt. Before I put this pump in, I always like to use a little bit of dielectric. We'll go ahead and lubricate this well here. We'll go ahead and slide our pump in, 310 millimeters. Now they do make a metal impeller water pump for these older engines, the 1.8s and the 2-liter non-turbos. I found that the OE ones, especially like the newer revisions, work pretty well and don't have that super come apart problem that they used to 15 years ago. And we will torque these to 15 Newton meters. So we have our water pump on for our full timing video. Before we install the cams properly, we need to get these little babies on. These are like alignment dowels for our cam caps and our cam chain tensioner. Make sure our sealed surfaces are nice and clean. Now let's get our cams set in. I already got the chain on the cam. Since we already did all the timing, I was able to mark our new chain, so this should go pretty easily. That's mostly lined up. Try and get the cams as close to TDC cylinder 1 as possible, which means that these lobes here for cylinder 1 both point inward. Now, before we get too carried away with our cam adjuster, we need to get some new feet put on it. These aren't too bad. I've definitely seen worse, but look at how dark they are. And we definitely don't want to put this back together on a freshly built engine. So we'll go ahead and get this apart. Then these just pop off. And the new ones are usually a little harder to get on. So that kind of goes in like that. So there we go. There's our top one. Put that back on, and we'll do the same thing on our bottom one. Now that we got our new feet in, the next thing we need to do is we need to press this tensioner in order to get our tool installed so that it'll hold it all together. What I'm gonna do is I'm gonna take a couple zip ties. I'm gonna use some zip ties. It's not super hard to compress that spring, so if you had someone to like hold it for you, or you could even put it in a vise, that would be ideal. Now you don't need to compress it all the way. You only need it enough to get the tool started. I actually think that's enough. Get off. There, get that out of the way. When these are new, you're compressing oil pressure and spring pressure, so you gotta be extra careful. Next up, we need to get our cam adjuster gasket, which is actually 2 gaskets, the little half moony guy and the metal guy. Now here on the backside of our cylinder head is where our cam adjuster goes. This is our coolant flange. We have our little half moony guy, and I like to put a little bit, not a lot of it, a little bit of silicone. It's enough to fill the gaps, kind of like that. With our tensioner on, now we gotta put our cam caps in. I'm gonna make sure our seals are tucked where they need to be. Now, I'm probably gonna replace these seals. Problem is, holding the camshaft to get the gear off is usually pretty tricky. So we'll get everything mounted up. Then I think I'll pop the gear off and replace the seal. I already put some lubricant on there. Man, that stuff, I like how that stuff went on. That was nice. Then we'll go ahead and just drop our caps on. 5, 4, 3, 2, and then the back one. Same thing for the other one. Now, these are something that you do want to make sure you torque down properly, as well as follow the sequence so that you're evenly tightening these all down. The other critical step before you tighten all this stuff down for the camshafts, you need to make sure you roll the crankshaft back a couple of teeth. You don't need to go crazy with it. Since this is an interference engine, if your cams aren't timed properly and you tighten them down, it'll push open one of the valves. It can actually bend a valve or doink a piston. So we don't want to do that. We just want to back the crankshaft back just a little bit. We're going to start by tightening 2 and 4 first. And we're gonna tighten 2 a little, tighten 4 a little, tighten 2 a little, tighten 4 a little, tighten 2 a little, tighten 4 a little. You can see as I tighten this down, it'll slowly move the camshaft into place. Then usually for the final little bit, I'll just go by hand. Now, we're gonna torque those guys down to 10 Newton meters. The next ones we need to tighten down are the 2 at the back where the chain is. After torquing these down, that'll allow us to check our timing on the top side of the engine and make sure that we're all timed up. Now what I can do is I can finish tightening down the rest of our cam caps that aren't tight. All these are 10 Newton meters. Okay, before we get crazy with our timing belt, let's go ahead and get these cam seals done. I'm gonna do the intake cam first. This little ring here is for the cam sensor. You can see it only goes on one way. In fact, just go ahead and take it all the way out. I mean, honestly, this seal probably was fine, but since we have a new one, we'll go ahead and slide it on. Now, if you've never replaced a cam seal, something you can do to open this up a little bit is take a socket and just kind of stretch it carefully. We'll go ahead and put our ring back in and put a little blue thread locker on our bolt. And I don't think that's gonna be enough to rotate our engine around at all. 25 Newton meters. Next up, we gotta do the cam gear, which generally is a little trickier than doing this one. You can zip this off with an impact in most cases. You don't have an impact that'll knock that off. You're gonna have to hold the gear using a cam bar like this. Odds are this bolt is probably a one-time use guy. Pop that off. Clean this out. Same thing we did for the other one. We'll slide this little guy on here. We can actually put that guy on. Go ahead and snug this cap down. And since we're here, let's go ahead and torque that back to 10 Newton meters. Go ahead and get our gear put back on. Now I have heard tale of people putting these on backwards. Make sure that you put the gear back on the right way. Otherwise, you're gonna have a bad time. Just like we did for the intake cam, I'm gonna put a little thread locker on this guy. Now in the repair manual, it actually doesn't call for that to be replaced, must use. Now it may call for it somewhere else in the repair manual, but not in the like breakout. So we're gonna torque this thing to 65 Newton meters and call it good. Okay, now we can move on to our timing belt, which is pretty straightforward. We have a hydraulic tensioner that goes right here. Next, we have to put our roller on. Now this roller should have a washer on the back side of it. Mine didn't, but somehow miraculously in my pile of nonsensical things, I found one that I think is actually from 1.8 turbo tensioner. For our bolt replacement here, we actually need to hold this gear. This is a big boy torque spec of 90 Newton meters plus an additional 90 degrees. And for that, we need this guy, this Long John Silver's guy right here. What this does is this bolts to our gear so that we can counter hold it. So we'll go ahead and get that mounted up. Counter hold, get our old bolt off. This bolt comes loose, we're gonna have a bad day. This should be a satisfying click. That wasn't nearly as satisfying as I was hoping for. Yeah. 90. Even the camera felt that. While we're down here, go ahead and slide our crankshaft to TDC. Well, now we can keep grooving on our timing belt. We'll pull this roller off, drop our valve cover on to make sure our cam's at TDC. We're 1 tooth off on the top. There we go. Pop our belt on. All right, there is our belt. We'll go ahead and torque our roller down, and then we'll pull our pin, rotate our engine around twice on the crankshaft side to do 1 full revolution of the camshaft. There's 1, 2. Go ahead and tighten down our roller to 25 Newton meters. We are on our way. Now that our belt's on, we can start to put our covers on. That's always a good day. Because of the way our engine is mounted on the engine stand, we're not gonna be able to do the rear main seal or the clutch or anything like that with the engine on the stand. So what I have is this really awesome Eurowise mount that mounts right here to the engine. Instead of the engine being the way it is now, this will go in the tube, so our engine will basically be 90 degrees different. Ta-da! Probably what's gonna be the worst part of this whole job is we gotta take this off of that side and put it on this side. Now that we have our engine mounted up, it's time to work on the back of it. This rear main seal actually has the gasket kind of attached to it already, so we don't really have to worry about that. We do have to be careful of the seal itself, make sure that goes on the crankshaft properly. It's important to note the way this seal goes on, the lip actually has to go backwards, so it's a little weird. You gotta be extra careful. You can take this guy off, 6 bolts, 15 Newton meters apiece.
And with that being said, I think we're at a really good stopping point. So coming up on the series finale, we are going to install our engine, fit our turbocharger, overcome a few issues, and take our TT to the dyno to see how much power it makes, and hopefully it doesn't blow up.